Okay, so an exponential function is any function that takes the form of the following here. For us, f of x is equal to a raised to the x power. That's it. That's that simple. For right now, we're going to start off pretty easy. F of x equals a to the x. There are two parts that we want to talk about. One part is this thing down here. That's called the base, as you could probably imagine. The base. And what would we call the x up here, since it's called an exponential function? What do you think? Yeah, that's not a big surprise, right? That's the exponent. So those are the two parts that we have of an exponential function. We have a base and we have an exponent. And we have a few key points that come along with exponential functions at this juncture in our education. And the first one is that a needs to be greater than 0 but not equal to 1. Okay, if it's less than 0, something else happens. If it's 1, what happens? Anybody see it? Yeah, you get 1 to whatever is going to be what? 1. So all you get is a line of y equals 1, which is not very exciting. We studied lines way back in algebra. And the other thing that's really interesting is that the domain of any exponential function that takes this form is just guaranteed to be all real numbers. We just say thank you. It's something we put into our brains and use as we need it. Okay, so the domain for exponential functions is going to be all real numbers. So we can just say thanks. We'll use that. All right, you guys feeling pretty good so far about that? All right. So remember, we got two parts, a base and exponent. A has to be greater than 0 but not 1. And the domain is all real numbers. So the guiding question I wrote on the left is, what are the two parts of an exponential function? You probably can already answer those questions. You're going to need your graphing calculators for the second box. So if you don't already have them out, go ahead and take them out. If you don't have one, you can watch mine. Okay, I'll do the first one with you. All right. And what we're going to do is we're going to practice evaluating exponential functions, and we're going to round to 3 decimal places. Yeah, I'll use that one. So the first one is 3 to the 1.2, so I'm going to turn my calculator on and take 3. Now the button that you want to make sure you know about is the caret button. The caret button is the button that's right above the division sign, so 3 to the, and then I'm going to say 1.2, and then push enter. And if I round that to 3 decimal places, Andrea, what do you think you get if you round that to 3 decimal places? 3.737. There you go. It's just that easy, right? So we're going to use about 3.737. So right now in your little family of groups here, this is your family, go ahead and do B, C, and D. See if you can find the pi button and see if you can find the E button. And I'll record this and turn it back on. So let's do B, 2 to the negative pi. Randy, what'd you get, buddy? Yeah, we got about 0.113. Do we agree? Yeah. Okay, who has part C? Yeah, Jonah. About 0.001, you are correct. And part D, did you find the little E button? Daniel, what'd you get? 5.474. Is that what you guys got? Yeah. All right, good. So you guys can evaluate on the calculator now. All right, I'd like to talk about graphing exponential functions by hand. I'll do the first one with you and show you the key points. And then you and your family will do B, C, and D. D is down here. And it's actually a lot easier than it looks or sounds, right? So if we're going to graph the exponential function f of x equals 2 to the x, here's what we're going to do. We're going to set up a little tiny table, x and f of x. And all we're going to do is analyze a couple of points. First, I'm going to analyze if I plug in a 0 for x, what is the output? 1. Yeah, 1, because anything to the 0 power is 1. I call this the guaranteed point. That's the guaranteed point, right? 0, 1. Because when you plug in 0 for an exponent, you're guaranteed to get 1. That's a little rule that we learned way back in like the first week of school. Now I'm going to plug in when x is equal to 1. If x is equal to 1, what do I get out? I get 2, right? Because 2 to the first power is 1. You know what I call that point? I call that point 1, base. Now, why would I call that base? Because the base is what? Okay, so I have the guaranteed point, and I have 1 comma base. Then on my graph paper, which is why we're using graph paper today, I'm going to go every 2 units. And plug in. So I'm going to have 0, comma 1, 0, comma 1, and then 1, comma 2, which is the base. So my exponential function takes the shape of this right here. Kind of looks like that skateboard ramp that we spoke about earlier, right? Yeah, kind of looks like that, right? Yeah, so that's something else. We'll get to that in a second. All right, so you have 0, comma 1, the guaranteed point, then you have 1, comma base. Go ahead, take about 2 minutes, and graph B, C, and D with the rest of your... All right, so take a look at mine up here. Does yours look something like mine over here? Yeah. Right. So all 4 of these types of graphs are a certain type of exponential functions, and they are what we call exponential growth. And exponential growth happens when to your functions when your a value is greater than 1. So all of these are examples of exponential growth, and the reason it happens is because our a value is greater than 1. All right, so you may be wondering, how do you get exponential decay then? Well, that happens when your a value is not necessarily negative, but in between 0 and 1. So let me give you an example of these 4. I have A, B, C, and D. I'll do the first one with you, and you can do the last 3 quickly with your family there. So again, I'll make a little table to demonstrate where I'm getting these points from. Again, if I plug in 0 to f of x equals 1/2 to the x, what do you get out? 1. You still get 1, right? That's still the guaranteed point. Okay? But if I plug in a negative 1, if I plug in an exponent of negative 1, what's 1/2 to the negative 1? 2. 1/2 to the negative 1 is 2. You know what I call that? I call that negative 1 comma 1 over base. Now, why do I call it 1 over base? Because what's 1 divided by 1/2? 2. Yeah, not 1. 1 divided by 1/2, right? Is 2. So I call it negative 1 comma 1 over base. So here's what you get in the graph. So you want to think about this when your a value is in between 0 and 1. And a, in this case, is 1/2, is between 0 and 1. Hold on one second. All right, so I'm still going to have 0, comma 1, but now I have negative 1, comma 1 over base. And here's the graph that gets produced. Totally different than the one before, right? Yeah.
Why do you use negative 1?
Because it produces a nice spot on the graph to curve. If I produce 1, I have 1 comma 1/2, and I only get this little point over here. It doesn't tell me a lot. That's why. Yes?
So, negative 1, comma 1 over base is really just 2.
Yeah, exactly.
Okay.
You got it. Right? Because you guys remember, you do remember that 1/2 to the negative 1 power is equal to 1 over 1/2, which of course is 2. That's how I got that. Okay? Yeah, the base is 1/2, so 1 divided by 1/2 gives you the 2. And that gives you a nice point that gives you some kind of indication as to what the graph is doing. All right, guys, go ahead and do, why don't you just do B for right now, because we're kind of running short on time. So there's my graph. I have 0, comma 1, the guaranteed point, and then I have negative 1, comma 3, so 1 over base for the other easy point. Okay, all these functions represent exponential, well, you got it, exponential decay, and you get that when your a value is in between 0 and 1. So you can graph part C and D later. at home. So you get exponential k. Now, the guiding question I have on the left-hand side for you to consider is, how do you know if the exponential function is growth or decay? So you might want to see if you can answer that question later. Right? How do you know if you're dealing with a growth function or a decay function? There is something you can look at that will tell you the answer to that question. Yeah, if a is between 1 and 0, you have what? And if it's greater than, you have growth. Very good. Great. Okay, the handout. I love the guiding question here. Do you have it? That's a joke. Very good one. All right. The handout, please. So after just explaining what the handout does, take a look at this function and see if you can identify the two things that are happening to this function with your family right now. There are two things that are happening to this function. See if you can figure it out. Yeah, I'm going to do it with you. Okay. Who can tell me what is the basic exponential function that I have here? F of x equals what? 3 to the x. Good. Good. The second thing, who can tell me what is the plus 2 doing to my exponential function of 3 to the x? Yes, that is, so if I have the function f of x equals 3 to the x plus 2, that's going to be 2 units to the left. There you go. 2 units left. And then finally, my third function, what's the third thing that's going on here? Yeah, the negative of my exponent means I have, if f of x is equal to 3 to the negative x plus 2, that is a reflection where? You guys got it. Over y-axis. And guess what? You see how I've labeled it 1, 2, 3? That's how we graph it. 1, 2, 3. Does that make sense? So I'll do it with you. Here we go. I'm going to use a nice clean line here. Whoa, beautiful. Thank you. Oh, I think I messed this one up though. Oh, sugar plum. Let me try that one more time. Sugar plum. There we go. Now we're talking. All right, so the first thing I'm going to do is I'm going to graph 3 to the x. So I'm going to have, I'm going to go every 2 lines to get myself going here. So we'll do a good job on this one. You guys will be all set up. Okay, so I'm going to have 0, comma 1, the guaranteed point, and then 1, comma base, right? So my first graph is this one. Notice that's in black, and I'm labeling it number 1. So next color I'm going to use is number 2. And I'm going to move my 2 dots which way? 2 units to the left. So this dot goes 1, 2 to the left. This dot goes 1, 2 to the left. And then I have this function, and I'm going to call that number 2. And finally, my blue graph, my ending graph, I need to do a reflection where? So that means that this dot is going to end up back where it started over here. This dot is going to be 2 units away over the y-axis, and so I have this graph to end my drawing, my transformation. And if I wanted to just double check to make sure I did it right, I could plug into my y equals, I could plug in 3 caret, in parentheses, negative x plus 2, and then hit graph, and I should see the exact same picture, and I do. Are you guys feeling pretty good about that today? Great. That's our lesson right there.